Okay, so this is a welding rod that I'm going to use. You can see, well, hopefully you can see, it's gone mottly. It's got that much bloody moisture in the flux. If you try welding with this, you're going to get a rubbish result. Look at how it's coming off on the fingers. This is a Magna 707. I bought them for a specialist job that I did decades ago. What I'm just doing now is we're just brutalising it on the corner of the bench to chip most of the flux off. These are a 3.2 rod, which I thought, for some reason I thought they were 2.5s. So they're 1/8, not 332. One rod's probably going to be adequate to do the whole job, I would think. What I'll do is I'll go and stick this in the wire buff, and I'll buff the remaining flux off and make it look like a proper filler rod. And then what we'll do is we'll see if we can get a tack with it, or 4 tacks. I'll be back in a bit. Okay, so we're ready to have a bit of a go. Done a couple of things. Got my leather apron on, changed my glasses. Normally I wear, well, my prescription's about a +1.75. Normally the cheap glasses that I buy are a 2. These are a 3. When you're trying to do detail work, it's good, because I end up with a reduced focal distance that I can work in, but I can actually see what I'm doing a lot better. I could wear my ordinary rigger's gloves. They're basically the same gloves as what these are, but these are a proper TIG glove. They've got a bit more gauntlet in them. Yeah. Helmet set to shade 11. And I've dialed up about 130 amps because I'm tacking. So I want to get the heat in reasonably quick. I don't want to have to spend half an hour waiting. So we'll see if we can get a couple of tacks in, and we'll give it a go. Let's get you to where you can see. Let's get it. Okay, you're going to get flash because I'm going to put a mask on you, okay? We might do it when I'm tigging, but at the moment you're going without. Sorry, you might get it when I do the proper weld, but at the moment you're going without. That actually doesn't look too bad, but man, it has opened up on this side. Those of you who hear people talk about welding and the importance of getting your tacks right, that was touching. Look at how much gap we've got in there. Right? And it snapped that off nicely. Yeah, okay. We'll get that to index in again. And it has, we've got it locked in on a good index again. What we'll do is we'll change our tack sequence. We'll go here, see what we can get, see if we can get. I might have a bit much stick out there, but might just drop this electrode back a little bit. We've got about 12 or 13 litres a minute of argon coming down the line, so it's still sitting about where I reckon it should. We'll have a go to tack on this end. That's not what you should do. Got enough spark in there that I actually didn't need to add any filler rod. So what we'll do is we'll come back and we'll give this a rub. That's actually not looking too bad. So before I go any further, what we'll do is we'll have a look at it. Make sure that we're kind of sorta. Ding, you hear that? That just broke through that wall there that I didn't put any filler in. So that gives you an idea of the stresses that are in it because I'm doing it cold. Yeah, I'm actually not happy with that. That's a little bit too far away. We'll have to probably set it up on a plate, and we'll probably have to do it with a little bit more science. So sometimes it's worth having a go. Just having a look at the walls themselves. Yeah. So what we'll do is we'll set it up a slightly different way and we'll go from there. I'll be back in a bit. Okay, so we've got a couple of bits of 16mm flat bar that it's sitting on. I've dressed these back. We've got it clamped down here so that it's holding. It was indexed in nicely. Just re-index it, so yep, there it is. Nice. And I've come back to 100 amps. So we'll just have another go getting these tacks and see how we go. And again, that's opened up quite considerably. We should have learnt the lesson from last time. What we'll do is I'll hold that there, got the earth on there, get the tack in here. It's got that. And we'll get a tack in here and then we'll have to clean the tungsten, seeing as I dipped it. This time, it looks like we're on the money. Not bad there. Still got a little bit of a gap, but what I'll do is I'll weld this here first, and that should pull this up a little bit. That's the theory anyway. So we'll have a go and see what happens. I'll turn you off, we'll clean my tungsten, I'll be back again. Okay, so what I'm getting ready to do now is I'm going to preheat it, and then I'm going to weld it. Basically going to weld it in this position. And what I'll do is I'll put a root pass in, and we'll see how we go from there. Let's do some preheating. We'll do some serious preheating. It's one of the things I love about the big burner. It gets it hot quick. Okay. And we've got a time window too. We don't have to have it right spot on in that millisecond. So what we'll do is we'll start off with the root pass through the back. Which ain't going to happen. Which ain't going to work too well until I get the earth clamp on. So now that we've got an earth clamp on, we might be able to do a root pass. Now what I've actually got is I haven't got a bad weld there, just by letting it fuse in on itself. So now what we'll do is we'll try filling it in a bit with a bit of rod. What I'm not enjoying is the heat coming off. It'd be a great job for a TIG finger, I tell you. That's pretty warm. But that doesn't look too bad. I'll probably come back to that in a bit and give it another rub. Carefully turn it over and spin it around. And while it's still hot, we'll add some heat here. What you'll notice is that I've committed a few cardinal sins here, in as much as what I've done is I've been taking my hand away before the gas flow stops. The reason for that is you can only handle getting burnt for so long. Yeah. Don't grab hold of the ceramic cup while it's hot. Yeah. It's not as comfortable as I'd like it to be, put it that way. And I'm moving around a fair bit as I do it, because I can see the little bubbles of porosity in that, and I'm trying to chase them out while I'm actually doing the welding. what I'm trying to do is when I can see contaminants in the world, I'm running you've got 105 amps dialed up at the moment, and that's really pushing it for the size tungsten that I've got. I really should have a thicker tungsten, but I haven't got any 1/8. Understandably, everything's pretty warm. So what we'll do is we'll just fill in this a bit, and we'll keep going before it cools down too much. Oh, that's interesting. Another crack's become visible through here, so we'll probably cut that with the grinder. Another one through here. That might be as a result of the heat that I've put into it, but it's not going to matter because we can fix it now that we know it's there. It's probably as a result of the initial drop, but you can see them now. You probably couldn't see it then, but I could actually see it boiling here. There's no other way to describe it, but see the contaminants boiling off. Now that could be a couple of things. It could point to the fact that it's mediocre material. It could point to the fact that I haven't cleaned it off, or it could point to the fact that it's just absorbed plenty of contamination over a period of time. And it's probably a combination of all the preceding and all of the above. I'll just put a cutting disc on and I'll slice this out back in a sec. File. These are seriously good value. This is a Makita cordless version of it. The short snout is actually dearer than the long snout. They're 120 bucks in Australia. Worth their weight in gold. Now this isn't going to be easy. How am I going to get into this, onto this so that I can get it? Full penetration, you beauty. As you'd expect though.
I heard a ping. I'm just wondering whether... I don't think it has, but we'll... I don't like hearing those tings when stuff's cooling down. Usually a good sign that you've got a lot of residual stress in there, so let's put some heat into it. So now what we'll do is we'll leave it in its incubator to cool down, and hopefully what that'll do is it will cool down slow enough that it can relieve its stresses without going ping ping snap. And in, oh, what are we talking? 3, 4, 5 hours, maybe tomorrow morning, I'll come back and have a look at it, and hopefully I can chuck it in the lathe and just face it off. If this doesn't work, because it's, as I said, there's a bit of suck it and see here, it's worth a go. If this doesn't work, what I'll have to do is I'll have to attack it with a bit of silicon bronze, which just means grind it out, preheat it, bit of silicon bronze, have a go. Sometimes you just got to try stuff. I will admit that hearing ting ting does concern me, but ting ting could be a bit of scale coming off somewhere, although not likely. It's usually a pretty good indication on this sort of stuff that there's a fair bit of stress in there somewhere, which is why I put a bit more heat back into it. And the reason I was heating into there is I'm trying to trap some heat in the enclosure, and in the enclosure, because you really won't heat these bricks up. Like I can put my hand on these bricks, I can feel a bit of heat coming up through the gaps in the bricks themselves. You can have one side of those glowing red hot and put your bare hand on the other side, and yeah, no big deal at all. They're quite amazing things, and they're soft, they chip easy, they break, yada yada yada. We can go on about what they do, but for this sort of work, this $6 each. Yeah, they're $6 each. They're cheap. They're really cheap. You can do all sorts of things with them. I've got another one that I did a while back. I've got an enclosure
which I use for when I'm doing heat treatment. I put stuff in there and I heat it all up. It's made out of these things, and I heat it all up, and I can heat stuff up, drop it in oil, whatever. I use a lot less gas doing that. And the advantage of that is, obviously, because it lives in an environment, if I want to temper something, well, not so much temper it, if I want to anneal it, well then what I can do is I can heat it up, close the doors and just let it cool down at its, close the door, put a brick across the front, that's the door, and it can cool down over quite some period of time, and that anneals most of your carbon steels pretty well. Yes, it doesn't work with 4140, or no, it doesn't work with 4140 because of the time you need to work with that. You need to keep that at temperature and the rate you need to cool it down at. And again, it doesn't work with some of the tall steels either. But for most of the stuff that I want to do, it's more than adequate. You know, if I want to heat treat 1045, as an example, because I like 1045 because it's water quench. And it's almost idiot proof, which means that I possibly fail 50% of the prime, 50% of the prime, 50% of the time. Yeah, no, you can hit numbers pretty easy with 1045. You can anneal it in your oven, providing the missus isn't watching. If she catches you, well then you probably want to make sure that that lump of steel is pretty soft because it's going to hurt. But yeah, so we'll see how that looks, and we'll chuck it in the lathe later on and make it kind of sort of flatter.